Welcome back, everyone. This is the last part. I promise you the last. And this is still continuing from 4.8, applications of trig functions, okay? All right. This is the last part and the most fun probably, okay? And this thing is using the last information that we learned, which is bearings. Always, you're going to sketch and you're going to label everything before you start the question, okay? A ship leaves port at noon, okay? So at noon, 12 p.m., it heads due west at 20 nautical miles per hour. So again, this is the rate. At 2 p.m., the ship changes course to north 54 degrees west. Now you know what this exactly means, right? As shown in the figure. So we're going to draw the figure. Find the ship's bearing and distance from the port of departure at 3 p.m. So that means 3 hours after. This is 2 hours after. Okay, so let's draw, okay? Write the question down because I'm going to move it up so maybe you can't see anymore, okay? All right, so now what we're going to do is this. We're going to sketch. So remember, we started here, right? I started here. So I'm always going to draw a little micro compass, and I'm going to go west. I'm going to travel west. I'm going to travel west. This is how I start. So this is the port, and this is at 12 p.m. And how much do I travel? Well, it's 20 nautical miles per hour. That means I traveled, you're right, 40 nautical miles. So remember, this is because I traveled 2 hours because I arrived here at my next destination at 2 p.m. It wasn't a destination though, right? Because my destination is actually where I end up, but I changed course of direction there. So I'm going to actually now start at 2 p.m. What happened? The ship changes course to north 54 west. So again, I always start from the north, right? This axis here, but west 54. West is going to the left. So I'm going to go 54 west. So I'm going to write 54 degrees there. That's 54 degrees west. Now I'm going to draw that. How much did I travel there for? That in this direction I travel for, well, it looks like 1 hour because I arrived here at 3 p.m. Right? And that's my ship here. So I'm going to draw my ship. What the ship? Right? That's my ship. And it's at 3 p.m., 1 hour. That means it's still traveling the same nautical miles. So it's 20 nautical miles. This is 40, this is 20. Now my ship's here. It says here, find the ship's distance from port. So from distance from here, right? So I'm going to draw the distance from here to here. From port, so that's distance from port and bearing. Now this is the tricky one and I'm going to explain that to you. So I'm going to have to look for bearing and distance, right? Sorry, this doesn't look quite straight, but it is straight, okay? So it's straight west and then straight northwest. Departure at 3 p.m. is here. Distance from port to the ship, but also the bearing from port. That's the thing. From port means it's from here to here. That's what I'm looking for. So I'm going to label that as theta prime because I want to part this weird triangle here. It's not a right triangle, but it's not the wrong triangle either, right? So I'm going to make this guy theta. But once I get theta, I have to calculate theta prime. Okay, and that's pretty easy to do, as you can tell. So now I'm going to move this up. We have our picture here. Okay, we have our picture here. Now, I know for me, it's easier for me to work with trig functions, which are sine, cosine, tangent. So what I'm going to do, I'm going to make a right triangle here. That makes my life so much easier, I think, okay? Now, if you know other methods, you're allowed to use other methods, okay? Now, I'm going to call this guy here, he's going from up and down, so I'm going to call this guy Y. This guy here, I'm going to call him X. From here to here. Well, then you know that the whole distance from all the way across, can I erase the 20 nautical miles per hour? Okay, because we don't need that information anymore. We already calculated into here. So that's going to be X plus 40. That's the whole distance, okay? Now you see a clear right triangle. That should be helpful to you. Well, let's see. Let's do the first. Well, this is the first thing you should do. What's the second thing we should do? Well, I kind of need the Y and the X. Because then I could get this leg and this leg. That means I could get the hypotenuse, which is my distance, which is what I'm looking for. So I'm going to set this question up so I can solve for Y. Now, I know that this is 54. That means this guy is what? 36 degrees. Ah, complementary angles, right? Okay, so I'm going to set up this as sine of 36. Why did I choose sine? Because I want to know opposite over hypotenuse. Because I know my hypotenuse is 20 nautical miles, and I know I need to find my height, opposite. So it's going to be opposite over 20 nautical miles. Okay, that's one. So my y value is 20 sine 36 degrees. Now, I'm going to leave it like this for now. Okay, even though I know I can calculate it in my calculator and this becomes 11.756 nautical miles, I'm not going to worry so much about this value. If you want, you can plug this into your calculator and store it. Let's actually do that, okay? So I'll show you two different methods, but new documents. So I'm going to use my documents. I'm going to say I don't want to save anything. Just make sure that you're in degree mode, and I've already changed it to degree mode on my documents form. So I'm going to type in 20 times sine 36 degrees. And I get something like this, 11.756. But instead of even writing that down, I'm going to store that right away. So I'm going to say answer, store this answer as y. Okay, as y. So I'm going to store that as y. Enter. All right, so that's safe. We're going to use that later. Let's do the second thing. I'm going to finish everything on this triangle first. I'm still looking for my x as well. Now, as you know, for x, I probably need cosine. Cosine of 36 is equal to x over 20 nautical miles, adjacent over hypotenuse. So 20 cosine 36 degrees is going to equal x, okay, approximately x. If you want to just leave it like that, that's okay too, but I've already calculated it for you, 16.180 nautical miles, and that's my second step. Now, if you don't believe me, let's go back here and let's type it in. I'm going to just cheat. I'm going to type this whole thing in. 20, not sine, but cosine, right? So I'm going to go to trig and type in cos of 36. I guess I have to delete this. And I get this value, 16.180, just right here. And don't forget to store it. So I'm going to store that sucker as what? X, because that's what it is. Okay? X. All right, let's go back to step 2. Wait. So you mean I know this and I know this? That means I know the whole leg, right? So then it means I can use Pythagorean theorem to find my distance from port to my ship. So that's my third step. Okay? So I know I can set this up as d squared equals x plus 40 squared plus y squared. And you know, in our calculator, we already stored them as y squared and y and x, right? So we can literally type that in. So let's try that, okay? D squared is equal to, not that I care about that intermediate value, okay? So watch this. So I'm going to go x, so I'm going to take my parentheses, x, literally type in x. You see how that's dark and bolded? Because they know what we mean by x. Plus 40, I'm going to square that sucker, and then I'm going to add y squared. Y, I've stored that value, that's why it's dark and nice, y squared. And let's see what I get. I don't care about that value though, because whatever that is, I'm going to square root it, right? So I'm going to square root that guy, so I get d is approximately. So I'm going to square root this whole answer here. I'm going to scroll back up to it, and I get that. So I know my distance is 57.397 nautical miles, and that's the first part of our answer. Okay, that was easy. You see how it makes it really clean if we just store it as x and y? Okay, let's go to our fourth, okay? Fourth step. We have to still find bearing, right? That's the distance. Now we have to find bearing, okay? Bearing is this angle here, but it's not this one we're concerned of. It's this one. So I'm sure you already know that this bearing is going to be what? We don't know how many degrees, but we do know direction. Yes, we have to go up, so that's north. But how about to the left? So it's going to be west. We should at least have that. Okay? We're trying to figure this out here. Okay? That's going to be our bearing. Okay? So let's go here. Well, we know everything about this right triangle except for this guy here. So what are we going to do? We're going to use tangent, huh? Tangent of theta, I don't know what that is what? It's going to be y, this whole thing, y over x plus 40. So that means the angle is going to be inverse tangent of y over x plus 40, right? So if it's y over x plus 40 is equal to our angle here. So again, we saved all that, right? We stored all that value in the calculator. So let's turn on our calculator. So let's literally go inverse tangent. But you know what I'm going to do, you guys? To be safe, I'm going to type in y divided by x plus 40 first. So y. So y is here, right? I'm going to divide by x plus 40. Isn't that nice and clean? Enter. That's 0.209. I don't care about that intermediate value. What I'm going to do is I'm going to do inverse tangent of this. And I get 11.819. So I solved for an angle just now, right? I saved for an angle, 11.819, right? That's degrees though. Don't forget, we found this angle here. It's 11.819. So what are we going to do with this guy here? We're going to find our theta prime by doing 90 minus this guy here. So let's do that. So 90 minus this angle here. And I get, ta-da! I get something like 78.181 degrees. And that's my answer. But you have to state it like this. North, 78.181 degrees west. So I'll surprise you with that. And these are the two things that we're looking for. Good luck with bearings. Bye.